So this guy made 64 trillion gems in his game using Raylib. So that means he's able to draw a bunch of meshes without too much of a performance hit. And I think that's really interesting. Because we made a 3D game in Odin the other day. And this is what it looks like. It's basically a 3D game where one tower in the middle continuously shoots. And we have UFOs approaching. And then you can upgrade the tower when you have enough gold over here. It's a very basic game. And you can see that we are not drawing much. The entire world is basically just a quad of pieces, tiles, that we draw in an array. It's like, I think it is... Well, let me lie, I don't know. 60 by 30 or something? Or 60 by 60? So not that much. And this game tanks down to 120 or 200 FPS, something like that. Which is bad, of course. And it's done in Raylib. But there's obviously ways to improve this, which is cool. And so I wanted to watch this to see what this guy can do. What we can do if we want to make another game like this in the future. Because I think that if you're making a game in C++ for the first time and you have no idea about all of these libraries, OpenGL, Vulkan, that's even worse. Maybe it's better for you to use SDL and Raylib to get started and make a game. If you want to make a game, of course. It always depends on what you want to do. If you want to learn, maybe these are not the best. But for making a game fast, that could be a first. For first time, yeah. For first time, to learn. Exactly. You didn't do culling, instancing, or anything to speed it up. Yeah, let's see. What can we do? I find this interesting. Let's see.
In my game, Moose Miners, there are trillions of gems that can be mined.
Yes, sir.
In my game, Moose Miners, there are trillions of gems that can be mined. The gems are placed in a grid that is about 32,000
Holy, so basically he's scrolling through all of them at the moment.
tiles wide.
And where's the FPS? He doesn't show.
About
Okay.
2 billion tiles deep. Each tile has a gem on it, which means there are about 64 trillion gems
Holy, what the hell is going on here? What?
that can be mined in
What's
total
this
on the map.
game?
With the current upgrades I have in the game, no one would be able to mine deep enough to mine all of the gems. But it is nice to have that huge limit to have the option to add some ridiculous upgrades
Bro,
that lets
what?
the moose mine really fast. So how
Let's
do you make something of this scale work without running out of memory?
Ostrich, it's not real time, yeah.
Stable frame rate.
He actually recorded this video in 1 FPS and then sped it up times 60 to make it look like it's smooth. 5-head move. What's the game
The
called?
problem can be divided into
I don't know, let's see. Moose Miners? Wait, it's actually a real game on Steam? Ooh, holy 69 mixed reviews? Bro, 350 reviews. I take that, bro. How much? Ooh, this guy's making money. Look at this. 10 euros. That's good. And then, yeah, sorry, you can't see it. Sorry, yeah, let's look at the reviews. You guys not knowing your Steam releases, SMH. Oh, really? Super cool. Knows every single game that comes out on Steam every time, man. Hell yeah, look at this guy. Knowledge big dick, man. Holy. Mixed. It's a tech demo, a training project, more than a full game at least. That's how it feels. It's fun for an hour, but after that, nah. So this guy says it's fun for an hour, but he played 13 hours. What do you mean, bro? Fun for an hour? That's not an hour. That's a bit more. Okay, less of a no, more like a eh. Overall, the game is a nice time waster, but it lacks offline progress, making it crucial you keep it open. I mean, that's not a big deal for me. I just leave my computer running anyways. Making it crucial you keep it open and making significant progress. I usually don't mind this in other incremental games, but this is because they are optimized for running in the background. Ooh, we're watching a video about optimization right now. Damn. So basically, it reduces the load on your PC while you play. Wait. I see. It reduces... Yeah. This game lacks that, so your PC is on load for the entirety of the time. Ooh, holy. I mean, this guy has 200 hours in the game, man. What? This game is an engineering marvel. My modern system can render 1 million objects in motion on screen at 200 plus FPS. Bro, that's done in Raylib. Okay, let's keep watching. Good game, man. I mean, obviously, right, you can always be more successful. But bro, this is a good game. Came out last year. Already that many reviews? Dev self-review? You think it's a dev? I don't think so, bro. No way. Let's see.
Two parts, the logic part and the rendering part. Let's start with the logic part. The logic is responsible for storing which gems are on the map and which have been mined.
Okay, so you have an array with 1 trillion slots. Okay.
As well as making it possible for the moose to find and mine the gems. I like to work in a data-oriented way when solving problems.
Ooh, this guy is... We too. The virgin... Yeah, soy dev. True. See, you guys are coming from Jonathan Blow that are still here. Yeah. These are soy devs, right? The OOP guys.
And with a problem like this, it is extra important to solve from a data perspective. Since 64 trillion gems can easily become...
Maybe it's just a huge bit field of 1 trillion bits. And if a bit is on, a gem is there. But you need more information. Like, for example, what is the color? Which type of... Maybe it's more than 1 bit. But it can't be too much more.
Too much data to even store on a typical hard drive. Just storing 1 byte per gem on the map would result in 64 terabytes of
1 byte, 64 terabytes. Okay.
data to store.
Yeah.
That would not fit on any consumer hard drive, and certainly not in RAM.
Wait, so if you have 1 byte, 64 terabytes divided by, it's still not enough. Okay.
And there is more data than would fit in a single byte that is needed for each gem. Each gem needs a position on the grid, a gem type, how many mines.
Do you really need a position on the grid? I mean, your position in... Let's say if it's an array, right? Then the array index is the position. But okay, let's keep going.
Mineable pieces that are left in the gem to mine, what color the gem should have.
Oh, I see. So the gem has HP. Yeah, color. Yeah, I see.
How much health the gem has left before it breaks.
Okay, I guess these two are two different things.
How hard the gem is to break, and possibly some more stats. Just storing these for each gem would result in maybe around 20 bytes if stored reasonably compact.
Position, 1 byte. What about bits? You could use bits, bro, for the type. That could be a bit. For the color, okay, maybe. I don't know. I'm not smart enough for this. Health, for sure. Yeah, sorry about the pauses. Okay, I'm just trying to understand the data, bro, because when you understand the data, you can understand the problem, okay, and how to solve it.
Packing, perhaps. Still, it would be much more than the already too much 64 terabytes of storage. There's no way we fit that amount of data in a game.
Okay.
The solution is to rethink the way we store the gems completely, and maybe make some compromises in the possible gameplay the game can have as well, to make this very large map work. So instead of storing data for each gem, I just store how many gems...
I'm so sorry, but I just find this amazing. Look at this, man. Holy, it all works.
...that have been mined.
Look at this. All of this works, man.
So far. That's for crazy. Each column in the grid.
What?
This means that I can reduce the data from 64 trillion instances of some gem struct or similar...
Sorry, I didn't get that. We need to go back. I'm so sorry.
Gem. What? I just store how many gems that have been mined so far for each column.
Rocks cleared. Are you store how many... Oh god, guys, I'm gonna pause every 2 seconds now. Oh no. Rocks cleared. Columns. Rocks per level. I'm already lost. Did anyone understand this?
In the grid. This means that I can reduce the data from 64 trillion instances of some gem struct or similar to just an...
4 bytes times 32,000. Someone understand this? Enable subtitles? Okay, I will. Sorry. I can reduce the data from 64 trillion instances of the same gem structure or similar to just an array of 32. Instead of having rock instances, he's using a counter. A counter. He's storing how many rocks in the position. Okay, so that's how many columns he has. And then he says that many rocks have been cleared. Oh, I understand. So I get. So he should have done like a visual representation of this. I get it now. So basically, if we have that many columns, if there is 1 rock in the column, that's the last rock. And then 2 rocks, 3, 4 and it goes down. I see. Okay, so now he knows. And since you can only go up, you need to get rid of this rock first in order to tackle this rock. I get it now. So he should have done some visual Okay, yeah. Thank you, guys.
32-bit integers that are about 32,000 long. Which takes about 128 kilobytes. Quite a difference.
That's not even a megabyte. That's crazy. Wait, kilobytes? Yeah, 1,000 kilobytes.
But with this solution comes some issues and limitations.
Okay.
Just storing how many gems have been mined in each column does not cover all the data as said was needed.
I understand what he's gonna do. I totally understand now. So basically, I see. So he's gonna do the... guys, this will be a spoiler, but I think that's what he does. He's gonna have an array of types depending on the number. So let's say 1, 2, 3, 4, that's type 1. And then 5, 6, 7, 8, that's type 2. That's it. Color, count divided by, something like that. That's my guess too, yeah.
4. Cool. Just which gems are left on the map and which are not.
It's amazing what you could do with this type of stuff, man. And man.
So we need some more arrays to cover the other things. There is another int array for the gem health that stores how much health is left in the most southern gem in the column.
That's smart too, man. Holy, that is so basically he's only storing the HP on the last one. Only here. Smart. Cool. Bro, you can really learn something from this.
As well as another int array that stores how many pieces are left to mine. Now let's think about the gem types. If, instead of just defaulting to storing the type for each gem, we think about the data that is...
Rocks have HP, okay, yeah, they do. Did you know that?
Actually needed, we can optimize it a lot. For the gem types, I want the gems to be more valuable the deeper into the mine you get. So by just deciding to have the types appear after each other, 25 gems at a time, we can just write the function that takes a grid position and returns the gem type.
Okay, that's too much code, but essentially what we did, right? Basically, more than this. Wow, that's even... Can't you use modulo or something? Probably not. But okay, I mean, that works too.
And I also wanted some more rare gems that are spread around here and there in the mine.
I can't mine from the
Gold,
side.
diamond and black gem. These are just placed procedure.
I think it depends where they go. They choose their own path, I think. But if you mine one, then you're just mining the last one.
By
Ekman would be proud.
The
True.
Gem type function.
Yeah, he would.
By passing a seed that is based on the position to a pseudo-random function, we can make sure that the rare gems always appear in the same spots as long as the same seed is used. Now, with this new way of storing the gems come some technical limitations that are going to affect the gameplay design possible.
Okay.
The main one being that only the gem most south in a column can be mined.
Yep.
So it is not possible to mine horizontally through any columns. That is a limitation I am fine with in order to allow a very large map and a very large base.
Yeah, I mean, it's like they are billions.
Can't directly control.
It's really cool. It's like they are billions. I wonder how they did it. Have you guys ever played They Are Billions? It's crazy how many enemies. Look at this. You see this? I wonder how they... Never mind. There's not a good... never mind. But basically, it's a lot of enemies. Yeah, it's a good game. Really good game.
All the miners, it is easy to uphold this limitation by just having the miners only try to mine gems that actually can be mined. Having a player-controlled character in the game would make this much trickier, and at the very start of development of this game I played with the idea of having a player-controlled character as well, that you could upgrade. But I decided to only have AI-controlled characters to easier support this way of storing the gems. Now, let's have a look at the other big part of the problem
rendering.
Of a very large map, the rendering.
Yeah.
There are a lot of different ways to tackle rendering, and I have gone through...
Yeah, so basically you guys set frustum culling, so everything outside of this view will be culled away. And then what else? Object instancing, and what else can we do here? Pre-watched? No, it's not pre-watched, bro.
Some different options during development. The first one is the draw model and draw mesh functions that come with Raylib. It is the most naive version, resulting in one full draw call for each thing you draw. And sets up matrices and textures for the model every time you call it, whether it's needed.
Every time! See, that's why it was so slow. It sets up everything every time. I get it, okay.
Or not.
Holy.
The big benefit of this is that it is very convenient to use, as you just call it with the model you have loaded and then it just works. The bad thing is that the performance is terrible if you want to draw a lot of things.
Oh yeah.
At the start of development, I used this for everything, just to get things going.
With instancing, you fix almost all the issues with rendering in that case, yeah. I guess then the solution to my problem would be instancing. Compute shaders for simulation. Yeah, maybe he does. We'll see.
At that time, I just used simple blocks for all the graphics, so it was not too expensive, and the scale of the game...
There's a cool video with devs on diplomacy. It's not an option 2 of diplomacy. It's not an option 2. If you want to, you can link that on Discord. We can watch this tomorrow.
Besides, the gems wasn't that large yet. I still use this to render the portals of the storage rail, since that is just 2 objects, so there's not much overhead that can be saved on those anyways.
Okay.
The next version is 2 sets of functions that are made based on a few Raylib functions, called draw meshes with same material and draw same mesh with same material.
Yeah, I'm not gonna read all of that code. Okay, let's just multiply, count, is stereotype enabled? Oh god, okay.
It comes with 2 different setup functions called begin draw meshes with same material and begin draw same mesh. Begin draw meshes with same material sets all the uniforms needed in the shader for a material, and begin draw same mesh pushes the vertex data of a mesh to the GPU. Then, when one or both of these are called, you can just call draw meshes with same material or draw same mesh with same material to render mesh. This makes the draw calls much cheaper when rendering multiple...
So basically he uploads what he's saying in layman's terms is, you have a mesh that is data, he uploads it once to the GPU, same for the materials, he uploads them once, let's say in an array to the GPU, and then he just draws with that data, because it's already on the GPU, don't need to upload it anymore. That's making it fast. Basically instancing, in a way.
Instances of the same mesh or rendering multiple meshes that use the same material in sequence. Using this method brings down the overhead when rendering multiple meshes quite a lot compared to using Raylib's draw model.
Yeah, so that's what we should do. So guys, would you like to see me revisit this game and we make it a bit more efficient? Would you guys like to see that? Like maybe after the demo version is out, we go back, make it more efficient, and then we add a little bit more gameplay features. Yeah? Because I'm thinking about doing that. It was fun to make this game. I think it can be a bit more fun. No, after the demo, of course. Make Gothic. In pure OpenGL. No, this is in Odin and Raylib. It's about this is the reason why we're watching this video, because we had the issue there.
Draw mesh. And these functions were really easy and quick to set up due to Raylib's very straightforward and easy to understand code. I used these for a few of the models in the game, the ones that need to be rendered in multiple instances, but not that many instances.
I wonder how he did the UI.
Storage minecarts and its rail. Now, some things in the game need to be rendered in very large numbers, such as the gems and the moves. For this, it is worth doing even better batching by using the draw instance draw calls available in OpenGL. Raylib has an example of this with their own draw mesh instant function.
But don't you need to have all of the positions of these gems in an array on the shader so you can draw them? At least the positions? Yes. So how much data? You calculate that on the GPU? You don't? No? So basically, I'm waiting for the geometry shader to create the positions.
This one works quite well and is a rather direct way of using the instance drawing of OpenGL. I did, however, make my own version of it since there was one big problem with it. In order for it to be simple to use, the drawMesh instance function takes an array of matrix structs, which is what Raylib uses for transforms on the CPU side. But in order to be sent to the GPU, it needs to be translated to a float 16 struct.
Oh gosh.
So the drawMesh instance function solves this by allocating a float 16 array and translating and copying the data from the matrix array to it. This is a big no-no. I want as few memory allocations when the game is running as possible.
See, it would basically allocate the entire array. Yeah.
No allocations that happen every frame. So I made my own version of this function that is almost identical, but instead of taking...
You know, this video can be summarized as, so actually, that's how it works and that's bad, so I made my own function, you know, and that's better.
Taking a matrix array, it takes a float 16 array directly, which lets me skip the allocation and copying altogether. So instead, when I set up the transforms for the instances, I just store them directly as a float 16 array. Using instance rendering makes the rendering much faster for the meshes that are rendered with a lot of instances. But for the gems, there is a problem. different gem types need different colors. And the drawMesh instance function only has support for unique transforms for
You use a material index.
each instance.
And so you have each material be there once. That is not too many, and then you just index into the array of materials.
So I made an extended version of it that also takes a color array to pass a color for each gem. This worked quite well, and now we can render quite a lot of gems without...
You should really visualize this a bit, because I'm getting lost. Are you guys still following the video bitrate?
Dropping too low.
Yeah.
But we could do better. Passing data from the CPU to the GPU is expensive, so we want to send as little as possible. It would be better if we could avoid having to send the color of the gems to the GPU. This becomes even more relevant when looking at rendering the gems in the miners' cards. There can be quite a lot of miners on the screen at once, and after some upgrades they can carry a large amount of gems, resulting in hundreds of thousands mined gems to be rendered.
100,000,
To solve this, we should go back to thinking data-oriented again. What is the color data of the gems really? How dense it is, for example? It's not really dense at all.
19 colors and 100,000 gems, about 5,000 gems per color. Yeah, so 19 colors, an array of 19 colors. Yeah, so that's what he does, yeah. And then an index into the array. Or you compute the index, because you know how many gems are left. Or something. But you still need to send the index to the GPU, I think. Yeah.
There's a lot of repetition in it, since the total colors of the gems are quite few, and most of the gems that are visible on the screen at once are...
I'll take a look, but I don't know for internships. We'll see.
...going to be of the same color. So, when looking at it like that, it is really inefficient and rather stupid to send the color value for each gem to the GPU.
Yeah, it is.
Instead, we can split the rendering of the gems into several render passes, one for each color. Then we can just set up the color of the material once per render pass, and skip sending the color for each gem completely.
Oh wait, so you have 19 shaders?
So this is what I did for the mine gems. I have this instant render pass struct that describes the render pass for the gems, and then I just have an array of these with one entry for each gem color. Then, when preparing the transforms of all the gems, I just select the render pass entry in the array that corresponds to the color of the gem and add it there. Rendering these is then really simple. Just loop through all the gem types and get the color for the type to set that to the material, and then call the drawMesh instance that does not take a color array.
Okay, I'm lost.
This solution also reduces the memory footprint by a lot as well, instead of needing a color value for each.
Yeah, I'm lost, but I mean, we're at the end of the video. I think the coolest part about this is the instancing that we would need to test, and it doesn't seem like he's doing any culling, or maybe it's just so obvious that he's doing culling that he doesn't need to talk about it. I don't know.
Each instance of gem that should be rendered. We only need to store a single instance render pass struct per color. That was all for this devlog. If you liked it and want to see more like this, please...
How do you draw? Okay, like you're not culling anything? You're drawing a trillion triangles? Okay.
Wishlist most miners on Steam. It will help me keep making videos like this. And tell me in the comments...
Man, this is cool, man. Really good video. 1 year ago. Very nice. See, guys, he links his game in the description. Isn't that interesting? A video with a description of linking to the game? Wow. Sounds stupid, yeah. Why would you link your game in your video description? That's bad. Really good video, man. I hoped he would have gotten, even in Paint, just explained a little bit more about how the data flows from the CPU to the GPU. He lost me at the end there, but I think we get the idea that you can do some really cool stuff to... The title is clickbait though? No, but it does run like that. We read through the reviews, bro. It actually does run very efficiently. Yeah. Like this is a real... Okay, so you're saying that this is the game developer. I don't think so, man. I don't think so. He's smart. Yeah, he's smart. Yeah. Anyway, so if you guys would like to support this guy, because we watched the video right now, you watched it through me, you can rewatch the video at 1% volume, and then basically switch tabs to something else, do something else. Give him the playtime of the video so it supports him. YouTube gets good feedback from the video, and hopefully gets boosted more, because I think it's a good video. It's some interesting stuff to think about. No? What do you mean no? Really toxic.